Hello, I'm Craig Guthrie, editor of Mining Magazine. Today I'm here with Martin Provencher, industry principal mining metals and material with OSIsoft, now part of AVEVA, to discuss the findings of a joint survey on how the digital transformation can revolutionize the aluminum industry. The surveys of respondents featured producers from the top 200 companies. Now, of course, OSIsoft is deeply embedded in the transformation in a number of industries. You have specific and useful experience in this industry, Martin. Can you tell us about that?
Yeah, sure. Hello. Thank you. Yes, actually, I've worked in the aluminum industry quite a few years ago. I've actually been the IT and automation director for a large aluminum smelter in North America, in Canada. Of course, back then I was producing kind of a multi-year strategic plan on operational data initiatives and how digital transformation could help. That was something like 20 years ago. Um, then I moved into kind of investigations, did some investigations for carbon plan, reduction area, cast house. Um, so investigation on events, on quality issues that we were facing and things like that. And then after that, I moved as a production director. So I was in charge of operations and maintenance for 7 different areas of the plant, including the cast house, so cast house, energy management, um, gas treatment centers, etc. So lots of different areas. So that's basically where I got all that expertise. It was at that time it was the 5th largest aluminum smelter in the world, um, called Aluminerie Alouette. And now, again, like I said, now, like you said, I'm now working with OSIsoft, which is now part of AVEVA, as the industry principal for that industry. So here to help customers understand what is it that they can do with their operational data.
Great. And then given that sort of lengthy and varied experience in different parts of the value chain, was there anything in this survey that surprised you?
Yeah, that's a very good question, actually. In terms of surprise, I would not really surprised, but I would say happy to see that climate change was actually the biggest challenge for most smelters. It's actually a good thing. Of course, smelter is producing uh, some emissions, so and all smelters are trying to reduce their emissions. So I think it's a very good aspect in most areas around the world. We've seen it as the number one in the survey, number one challenge. Europe, Middle East, Africa, APAC, and it's quite challenging because, of course, when we're talking about producing aluminum, we're basically reducing the alumina, extracting oxygen out of the alumina and using carbon. So it does produce CO and CO2. So for sure, companies are looking at ways to improve that aspect. I mean, we can think about the ELYSIS project that they're trying to produce aluminum with a carbon-free process. So there's quite a lot of advances that are going on in that way, which is a good thing. But still, there are still lots of improvements that can be obtained with existing smelters. For example, when I was at Alouette back 20 years ago, I mean, we did implement some environmental aspects or environmental monitoring systems for fluoride emissions, so that when people are operating, operators need to lift the hoods to change anodes and things like that. So there's a big impact when they have to remove those hoods and they have to put it back on place. So if operators don't know the impacts of removing those hoods, if they don't see it, they don't understand it. So what we did back 20 years ago was actually to implement visualization screens where they were able to see in real time the emissions that were coming out of the pot rooms. So that was a good example of what we can do once we start leveraging that data. So that operational data coming out of those, or in this case, we're talking about environmental emissions data. Um, and it's good that companies are now looking at ways to help and finding new ways to help in terms of climate change. So I think this is a very good news in terms of the results of that survey.
Yeah, and then looking at the sort of evolution of that visualization that you were working on, we now have digital twins in play. And one thing that surprised me in the survey would seem to be the kind of mixed response to them. For example, only 40% were planning to implement them, 10% said they were not the right fit. What changes do you think that we will see in the industry with an increased use of digital twins?
Well, I guess it's probably more into the fact that companies probably, I mean, some companies probably just don't know about the potential they can get out of a digital twin. You know, in that survey, I mean, we've also seen that the second most important aspect is in terms of challenge is productivity, improved productivity, and it actually includes process optimization. And I think this is where digital twin can play a big role. I mean, in terms of process simulation, in a pot room, it's very difficult to do some changes on a pot while it's in production because it can have drastic impacts, and also it can have some safety issues. Also, it can represent some safety issues. But from a technology or from a development perspective, we want to do some changes on a pot. We want to try different things. And I think this is where digital twins comes into play. If a digital twin can help us simulate those changes that we're trying to do on a pot, then it can help us identify that there are some risks if we do implement one specific aspect or another one. So, and this is where I see digital twin can play a big role. Of course, in order to succeed in having a successful or in having a good digital twin, you need to have all that operational data available. And that's where companies are facing a big challenge, is that they are having a hard time getting all the data. There's a data in the pot control system, there's data in the pot feeding system, there's data in the anode production system. So it's very difficult to combine all of these into one platform. And of course, once you have that operational data platform available where you can connect to all those different data sources, then you can start thinking about having a good digital twin that will enable you to do those simulation, like, for example, if the anode density is being reduced or is being increased, if the oxygen reactivity of the anode combined with the temperature of the pot, combined with the amount of bath that you have in the pot. I mean, those different aspects can all be put together into the digital twin so that you can do simulation, and of course maybe find some improvement areas for the anode plant. So maybe if we change something on the anodes, it would have a significant impact on the pot productivity. So this is where I think a digital twin can play a big role in terms of improving productivity. Of course, the challenge again is really to make sure that you have access to all that operational data coming from all those disparate systems around the plant. And this is where one good operational data infrastructure like the PI system can really play a big role before you get into a digital twin usage.
Sure, and that sort of played out in the survey's findings, because 40% of respondents said that the data platforms that can consolidate data will have the biggest impact on their organization over the next 12 months. But once we have all these huge wealth of data being generated, how can we then leverage that into optimizing processes?
Yeah, well, you see, having the right data platform will, and that's true, I think, and it's a finding of that survey, but I think this is a very good one, and I strongly agree with that. I mean, having access to all that data is a challenge for smelters because, like I said, I mean, you have many different control systems. Typically, when you buy an asset, it comes with a control system. So throughout the whole plant, and an aluminum smelter is kind of a big plant, and we can divide it into three different plants. The carbon plant, the reduction area or the electrolysis plant, and the cast house plant. So three different plants, different assets, different control systems. So it's very difficult to have one single view of the whole thing, of the whole supply chain. So that's why it becomes very important to have the right data platform so that you can connect either to those control systems automatically, so to collect all that real-time data, because of course a control system controls its own asset, but it does not take into consideration everything else that's surrounding the asset, or everything else that's coming from another plant. And the best example is, like I said before, I mean, if you cannot have the access to the anode quality perspective or the anode quality um, properties, for example, like I said, I mean, the anode density, the anode oxygen reactivity, and things like that in your pod control system, then you are missing some aspects. Of course, having the right data platform allows you to have all that information into one placeholder. And then what you can easily start doing once you have that right data platform is to start do condition-based monitoring. So condition-based monitoring on your process, condition-based monitoring on your maintenance perspective, on energy consumption perspective, and things like that. And this is what the data platform brings you in terms of high value, because now that you have access to, and coming back to that pot example, now that you have access to the pot feeder system, you have access to the anode system, you have access to the pot controller system, you now have all that information into one placeholder, your operational data platform or your PI system. Now you can easily implement those conditions that every process engineers know. They know what's causing an anode effect. So they know which conditions should be looked at to reduce those anode effects. They know what conditions should be looked at to improve the pot's productivity. And those are the things that we should implement also into that data platform, so that not only will we be able to capture all that real-time operational data, but we will also be able to do something with that data in real time, condition-based process monitoring, for example. The other example I was talking about is about maintenance. Once you start gathering all that data from your assets, you can easily start do condition-based maintenance, because you know the conditions. Reliability engineers will have done RCM, or reliability centered maintenance analysis, on failures or downtimes, and they will find the root cause analysis. They will do a root cause analysis, and they will find the conditions that led to the failure. And those conditions should all again be put into your operational data platform, so that they are being monitored in real time. So I think it's good that a lot of companies, a lot of organizations see that there's a value in getting that right data platform. Now the next challenge is, once you have collected all that data, you need to start doing something with it. And that's where I see the biggest challenge resides, is companies are good at collecting that data within their platform, but from a visualization perspective, now we need to move a step further. And what we see in most cases is that companies are looking towards AI, advanced analytics, but there's a huge value we can get out of what our engineers already know. Reliability engineers, process engineers, and that's what we're trying to leverage on, their expertise. And then after that, what is it that they don't know? And this is where we will start bringing in analytics and AI platforms.
Right, and obviously OSIsoft has been working on the transformation in this industry for some time. This survey looked at the future, but do you have any specific examples of how this has already helped companies, these data platforms?
Yes, we have lots of companies that have done good presentations. Um, For example, I mean, in terms of visualization, Alcoa did a very good presentation. Alcoa, which is a large aluminum producer around the world. I mean, they have done great, lots of good presentations where they were showing how they were using all that operational data. First step, visualize what's happening in your plants, in your smelters, and they started visualizing what's happening in their smelter to change their operational procedure. So, for example, shift changes. They were able now to look at real-time data instead of looking at past data or past reports. Now they look at real-time data for their shift changes. So this has brought some significant improvements for Alcoa. Now Alcoa is able to see globally in all their smelters what's happening. Also, from a maintenance perspective, having the ability to to implement real-time condition-based maintenance or even predictive maintenance. Again, another good presentation that Alcoa again presented. I think it was last year or 2 years ago. And this is publicly available on our website. So Alcoa did implement predictive maintenance without the need to add any new sensors, but just collecting the information from there. And this was done at the cast house, actually. A very good presentation from Alcoa, where they implemented predictive maintenance and they showed quite significant savings in there. Um, Of course, I talked about environmental emissions where at Alouette, I mean, this was presented, I think it was presented back in 2005, if I remember. And again, a good example of leveraging that operational data. And in this case, it was the example I've provided to you from an environmental perspective. So there's a lot of different use cases that can be done. Of course, from an improvement perspective going further, I mean, as you can imagine, most smelters might not want to share what they're doing with digital twins or with advanced technologies. And of course, we can all understand. But we have customers that have presented in other industries. For example, in the cement industry, we have a customer, Cemex, that did present how they're using artificial intelligence to bring in or to implement autonomous operations. So, and in this case, we're talking about managing a kiln. A kiln is a big oven that's operated at 1500 degrees Celsius. So if they can implement, in this case, I mean, Cemex presented the kiln cooler, I mean, a subsection of the kiln operations, but this was a pilot project and it was a successful pilot project. So if you can implement autonomous operation for a kiln, I mean, you can implement autonomous operation for much more than that. And if we bring that into a smelter using digital twin technologies, using, of course, the right data platform, with all those new technologies, we can eventually start thinking about autonomous operations for a smelter. And there's a huge use case in there because, of course, from an energy consumption perspective, from an environmental emission perspective, and of course, from a process productivity perspective, there are huge savings we can get and huge improvements we can get in there.
Yeah, and as we noted, climate change was cited as the biggest challenge facing the industry, which of course is no surprise given its huge consumption. So in terms of the things that you've discussed there, using data, and obviously you've mentioned some aspects of this, but if we just delve a bit deeper, what are the best ways if companies wanted to start using this platform to improve or to reach their climate change goals? How do they first start going about that?
Well, again, that's a good point. I mean, I think the first step is to allow everybody to see what's happening. This is really bringing, and again, this is what we've presented when I was at Alouette, what we've presented in 2005. So this is the first step in improving. So having the ability for your operators, for operators to see what's happening in real time will definitely help them identify what they have to do. For example, if they don't know that having the hoods open is causing an impact, I mean, even if you tell them, if they don't see it, they don't really care about this sometimes. So, but when they see it, most people will do care about this and will want to have a positive impact. So they will close their hoods. You know, typically you have to open those hoods to do the anode change. That's normal. There's no way you can get out of it. But once the anode is changed, you have to close those hoods very quickly. So and you have to open those hoods not 30 minutes before the anode change, but at the time you are ready to do that anode change. You know, for example, if the if the machine is not ready to collect the anode and remove it and put the new one in place, I mean, there's no reason why you should open those hoods. So just having visibility, and visibility is the first step in terms of the analytics journey. And that's what I would recommend is first, make sure you do provide visibility to your operational people, operators, managers, etc. So that's the first step. Second step is definitely what conditions are you monitoring? I mean, you have, for example, you have environmental conditions that you have to comply with. Well, those conditions should be implemented into your operational data platform, because you want to have those conditions being monitored in real time. You don't want to act after the fact. You want those conditions to be monitored in real time, and as soon as you get close to the limits, you want to be notified. You want to know what's happening in real time. So this is probably the second step. And of course, a step further is to start using those advanced technologies like we talked about earlier. I mean, digital twins. How is it that we can improve the process without touching the actual process? So using a digital twin to do simulations will allow us to do some tests, will allow us to do the different tryouts, and then we might be able to find some new ways to reduce our environmental emissions. So from a climate change perspective, there are definitely lots of initiatives that can be done quite easily, again, once you have that operational data platform that is collecting all your operational data and you start doing something with it.
Nice. And now the aluminum industry is challenging, perhaps from two perspectives. One is in its sheer energy consumption. And the second is perhaps in terms of those ingrained processes, because in many ways, some of them have stayed the same for almost a century. So how do you approach the sort of thorny subject of change management when you're introducing these complex new concepts?
Yeah, that's a very good point, actually. Change management is very large, and I think what we've seen in that survey is that companies need to understand the value, they need to understand the benefits of going towards a digital transformation journey. I mean, this is the biggest challenge that we see, because again, not having access to the proper budget or fundings to do those transformation is a challenge that is really related to the fact that people don't know the value they can get out of it. Because here we're not talking about spending, we're talking about creating value for the organization. If we do move on to a digital transformation journey and we have such an operational data platform, having the ability to visualize the whole supply chain, having the ability to start improving, having the ability to start implementing real-time condition monitoring on, like I said, on process, on maintenance, on environment, on energy consumption, all these aspects. I mean, this is where you will get value. And this is what companies or executives need to understand, is that the value resides in what is it that you can do with that data. It does not reside on the fact that you're implementing that in that platform or that software. It resides in the fact of what is it that you're going to do with that data. And this is what we need to train people. So from a change management perspective, we need to make sure that executives, managers, they understand what is it they can do with that data once they have access to that data. We need to make sure also that engineers that are working on the floor, that are working on the plant, they need to know what is it they can do once they have access to that data. And of course, we need to make sure that operators also that are working on the shop floor, on the plant floor, they need to know what is it that they can see, what is it that what they are doing, what is the impact of their daily activities. And this is where you will start generating huge value. So from a change management perspective, we need to bring everybody on board and make sure that everybody understands the value of leveraging that operational data. And this will help us succeed in a digital transformation journey, because now everybody will understand the value they're going to get out of it. What's in it for me as an operator, as a supervisor, as a superintendent, as a maintenance, a reliability engineer, etc. So what is it? What's in it for me? And once people understand what's in it for me, they are engaged, and they are getting more and more engaged, and they are using and leveraging that operational data.
Interesting. And yeah, it was emerged as a huge issue on the survey. Some 46% of respondents said budget restrictions was the biggest challenge in the transformation journey. And going into that change management, what is the best way you think to incentivize people on the budget front, and to sort of show to each level of people at the plant that it's going to benefit them?
Yeah, well, I think, like I said, I mean, really seeing the value, because typically people will see the cost associated with technology improvements. For example, I mean, lots of organizations have gone through an ERP implementation. And of course, I mean, those are huge costs. Everybody will say, yes, we need it, but, they are surprised with the cost associated with it. In this case, we're talking about operational data. So it's very different. People need to understand that there is value in that operational data, and that's what people don't really know about. I just had a discussion lately with an aluminum smelter, and I mean, they are still using Excel spreadsheets. Most smelters are still using Excel spreadsheets for their maintenance activities. For example, reliability engineers, they do their RCM analysis, reliability centered maintenance analysis. They put everything, their findings, into Excel spreadsheets. I mean, this is good. This is a very good first step. But when they start realizing that if they would have that proper operational data platform, and some of them already have it, they just don't know they can use it. Once they start realizing that that operational data platform can do that condition-based monitoring for them, no need for them to continue putting all of that information into Excel. That data platform can do all of it for them. That's where people start realizing the value. And this is what we should start talking about. Spending $1 that generates $100 in 6 months. I mean, what we need to know is that there's $99 of value that we're generating in 6 months. This is what's important. This is what is good to know, and this is what most organizations don't really know yet. Because of course, when they're talking about technology, some of them are investing into advanced AI platform, advanced analytics platforms, lots of advanced technologies, which are good. But 80%, what we've seen with our customers, is that 80% of the value is obtained in the first steps of analytics that can all be implemented into that operational data platform. So real-time condition-based analysis for maintenance, for condition-based maintenance, condition-based process monitoring, things like that, will generate lots of value. And of course, the cost associated with that, I mean, and when I say the cost, it's the cost to implement. I mean, if you have a reliability engineer can implement by himself the conditions that led to failure of an asset, if he can implement it by himself, the costs are very low, compared to if that same engineer needs to work with a data scientist working on an AI platform that doesn't have access to all that data. Then it becomes a very large project. So that's what's happening in lots of organizations that I see, is that companies are getting into those advanced technologies, but we need to have the proper basis, the proper platform, because before we move on to those technologies. And we need to leverage that platform before we move on to those technologies. And that's really a step-by-step approach. So I think this is really how I would suggest companies to start with.
Hey, and talking about that long-term value generation, just finally, if I could draw you to one sort of question that really stood out to me from the survey. So climate change was cited at 36% as the biggest challenge that companies will face over the next 5 years. Very, very closely in second place was improved productivity at 34%. So they're almost at level pegging those, but they could potentially be seen as contrasting goals. Do you think that it's going to be possible for the aluminum industry to achieve both climate change objectives and improve productivity? Because yeah, they could be seen as clashing with each other.
That's a very good question, and the answer is definitely yes. I mean, if we just think about the anode effect in a smelter, I mean, if you reduce anode effects, you improve process productivity, and at the same time, you reduce your environmental impacts. So definitely, being able to leverage all that operational data is a key aspect, and and it will help in both ways. So definitely a successful digital transformation for aluminum smelter will bring key or significant value in both areas. And I'm not surprised, I'm happy to see that climate change is number one, but I'm not surprised to see process productivity being second and close to climate change, because typically most smelters, I mean, what they're trying to do, of course, their objective is to produce aluminum. So the more aluminum they produce, I mean, the more efficient they are. And they are compared, if I can say it like that, on a cost per ton basis. So if they can improve their tonnage, they can improve the tonnage, of course, it helps them improve their performance. So, but in some cases, improving the tonnage might be a challenge from an environmental compliancy perspective. So that's where I think both of those two key aspects can be taken into consideration and must be taken into consideration for those organizations to succeed.
Fantastic, Martin. That's all we have time for today, but I'd just like to thank you for your really interesting insights into how digital transformation will play out in the aluminum industry.
Thank you very much.